Hello students, welcome to Powertutorials. So today we are going to cover one of the most important topic of magnetic effects of electric current chapter, that is how the common domestic circuit system exists and what are the previous year questions, and also discuss about few concepts here. Okay, so as a topic, as I mentioned, today we are going to cover common domestic circuit system with questions. So let's understand what is a domestic circuit. Domestic circuit in sense daily life, like a home. Inside the home, how is the circuit is present? That is nothing but the domestic circuit. Home needs, and I can say that household purpose. What is a circuit? Okay, not for industries. Okay, not talking about industries. Industries or software companies, whatever it is, there the circuit is different, but you're talking only to talk about the domestic, not the commercial purpose. Okay, so let's see how the circuit happens. Like what is the, is it AC, DC? First of all, let's understand. So in domestic circuit, we have AC supply. AC supply. So what is AC? AC is not air conditioner here. AC is alternating current. Okay, so AC stands for alternating current. So the name itself, it is saying that the current is alternating, that is changing. So how the AC current will I can say define is, it will be something like this. If I take, then this is the AC current. Why it is AC? Because it is alternating. Like you can see here, it is positive, here negative, again positive, negative. So it is alternating, like it's changing from one point to other point, and it is like changing again and again. Okay, so this voltage, this is called voltage here. This is with respect to time I am writing here. So with respect to Indian domestic supply, what we have is the frequency is 50 millihertz. So with respect to time, it is 2 milliseconds. Okay, so why it is 2 milli? Okay, not 2 milli, 20 milliseconds. Okay, so because frequency as a total, frequency is 50 hertz. So what is frequency? Frequency is 1 by time period. So 50 is equal to 1 by t. So time is equal to 1 by 50, which is 20 milliseconds. Milli is 10 power minus 3. Okay, hence the time period of the supply which we are getting is 20 milliseconds, and with respect to frequency of the ask, it is 50 hertz. Okay, so with respect to voltage and time, so for every 20 millisecond we are getting an alternating current, so alternating voltage. The voltage maximum value is 220 volts, and sometimes it is 230. Okay, let's read about 230 volts. Okay, 230 volts AC supply with frequency 50. Okay, so why only AC supply? Do you have any other supply? Yes, we have one more supply, which is DC current. Okay, so but for domestic purpose we don't have DC supplies, but we need to understand first of all what is AC and DC. So we have AC and DC. So what is AC full form? AC is alternating current or alternating voltage. Here it is C, so just alternating current. What about DC? DC is direct current. So name itself, it is saying that direct means there is no change in the supply. So with respect to graph, if I draw, AC will be something like this, alternating, whereas DC is direct means only one voltage. There is no difference in the voltage. Okay, so if I say 220 DC voltage, then it will be something like this, whereas 230 volts AC supply, it will be something like this. Okay, so with respect to graph, this is first point, this is second point. Which is better and why? In India, AC is better. Why? Because to make up or down, or else to increase or decrease voltage, we have an instrument called transformer. Transformer only works for AC. For DC we don't have transformers, because if we want to convert DC, first we have to convert DC to AC, increase up or down, again convert back into DC. So there is a lot of process taking on. Whereas for AC we can have the direct transformers where we can easily increase or decrease the voltage. Whereas for DC there is no direct transformers. No direct instrument to convert. So these are the main three differences for AC and DC. Okay, so if they ask about what is the differentiate between AC and DC, you have to just draw these three, that will be enough for you. Okay, Now let's go back to our domestic circuit again. Okay, so if we were going to draw the domestic circuit, what is the for the AC, not only for AC, if you remember our, at least our home, inside the home, if you see any switch here, for suppose like a TV switch also, if you see, there will be three holes. One is a big one and these two are small ones. Okay, so the big one is nothing but earthing hole, left one is main and right is neutral. Okay, so maybe you might have studied electricity chapter, there we have seen there is a cell here. So cell is the DC supply. For DC we will have positive and negative, whereas for AC supply, as I told you here, in domestic purpose we have AC supply. Okay, AC will not have positive and negative, but we have to say it is main and neutral. Okay, main is the one or the live wire, neutral is the negative wire. You can consider that, but it's not negative because it is an alternating every time. It is, we cannot say it is negative, but it is an like here the supply is coming and from where it is ending. You can consider in that way. Okay, so we need to have three wires. One is main, neutral, and earthing. So how it is coming is, first let's consider only two wires, main and neutral. Main is the live wire through which the power is supplied. We also call it as live wire, but as per science student you have to say it is a main wire, not a live wire. Okay, the next one is neutral. Okay, so first this live wire or the main wire are connected to electricity board main wire. Okay. Then this has to be connected to meter. Meter, I think everyone might have seen in your home. When the electrician or the person who is from the electricity board, he will come and he will check the meter, take the reading, and he will give you the current bill. So that meter we're talking about here. Okay, so let's suppose this is a meter here. Let's draw some kind of readings or table like this. Okay, this is nothing but meter. So this meter is connected to a distribution kind of switches. We also call it as MCBs. In your home you might have seen that sometimes if a geyser or heater or something gets high current, there will be kind of a trip happens. So what your parents will do, they will just go to the MCB and will just switch it on back. Okay, that we are talking about here. So it has different fuses again for different currents and different circuits. This is distribution bus. So from here we will connect it to the each appliance of your home. So I will discuss again this part again, because each apparatus in our home are connected in parallel combination. So why it is parallel? So this is main wire, this is neutral, and we have one more which is earthing. We have another supply. For suppose in second room we have like this. First is main, second will be connected to again neutral, and this is 7. Let's suppose only two appliances are there in home. Next is a third wire which are talking, which is earthing wire. So why the earthing is needed, I will explain. Okay, this is nothing but the whole circuit. So if they ask you to draw a domestic circuit, you have to draw all these points. First we have to draw main and neutral connected to electricity bus and saying that it has some one fuse, and then you have to connect it to the meter. From meter you have to connect to distribution bus where it has each fuses or each supply, and then we have parallel combination of our devices, and each one is main, other second part is neutral, and third hole which we're talking about inside is nothing but the earthing hole. Let's talk about earthing. What is earthing first of all? Why earthing is needed? For suppose in let's take the example of geyser itself. Okay, what happens if suppose by default the main and neutral gets connected each other? So what will happen? Short circuit happens. Due to short circuit, what will happen? Current will increase. So due to high currents, if passing through geyser, what will happen? Now geyser will get affected. So to divert this high currents outside, we use earthing. Okay, so what happens if you how it will divert means, if you remember the earthing wire hole, this will be larger area. So what is the resistance formula? R is equal to rho L by A. If area is high, resistance is low. Resistance is low, current is high. So whatever the high current is there, it will directly go to this large hole, because this hole has less resistance. So as the less resistance, like whatever the current is there, it will go to this hole. So from this hole, where it should go? It is mentioned earthing. So it is correct, because if you if you see any construction or anywhere in your home, if any current wiring is happening, just try to go there and ask that person, sir, where is the earthing wire for this house? They will say that all the rooms of the earthing wires are connected each other, and all three they will make sure to connect and dig it inside the earth. Suppose this is earth here, I mean the ground. So inside the ground they will keep all the wires inside, so that if anything happens to any appliances, that would flow to the earth and it will go inside the earth, because the earth potential we consider it as 0. Okay, so due to which, what are the high currents are coming of source, suppose we not set everything which should happen, but for the safety is very important for any electricity or any industry also. So for electricity chapter, the safety is much important. So yes, if any high currents is passing, we don't want to costly appliances like AC, fridge and all, they're much costly, like a 30,000-40,000 minimum will be there. So to avoid much damage, what will happen? Use earthing wire, so that those currents will directly go use the earthing wire and come into the earth. So that is the main purpose of earthing. Okay, I'm just repeating again. For consider example of geyser here. If suppose main and neutral wire gets connected to each other, they will get short circuited, due to which short circuit current will go high. If the current is high, you don't know the high current to pass to the geyser, because for every instrument it will have some reading. Like it can sustain only suppose this much, suppose 3 amperes of current it can sustain, or suppose 20 amperes of current it can sustain. If you go beyond 20 amperes, the device will get damaged. So to divert these high currents, we need to have the earthing wire. So this is one of the important question. They will ask you what is earthing wire and why it is useful. You have to say these 3 points, and just write in terms of 1 to 3 points, and just mention for to divert high currents from the device to earth, we use earthing wire. Okay, and second important question, why connections in home are parallel? So why it is parallel? Because if it is in series, let's see in opposite case. If it is in series, if one switch is off, all devices will be turned off. Suppose like this, we have switch here, and suppose this is D1, device 1, this is device 2, device 3, and so on. If one switch is off, all the devices will be turned off. Whereas in parallel, what will happen if I suppose like this? This is a switch, first device. This is another switch, second device. This is another switch, third device. All devices are independent to each other. Okay, this is the first one. So in parallel, all devices are independent to each other. So this is the first point. Second reason, in series, resistance is high. Why? Because in series, what is the resistance formula? R series is equal to R1 plus R2 plus and so on. So here the resistance will increase. Whereas in parallel, it is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here the resistance is comparatively, here it is high, here it is low. So if resistance is high, current is low. If resistance is low, current is high. So you have to say that in parallel, resistance is low, so more current can be supplied. If more current is high, the geyser, AC, whatever it is, they will give more energy. If less current is supplying, then the bulb also will glow very less. So these are the main points, and I hope most of the questions will be covered only on these 3 points. Okay, the first thing is you have to always remember this is the main circuit. This is one of the important. You have to draw properly each point. This is board fuse, this is meter, distribution MCB bus, and then the devices. This is D1, D2 are the devices, and these two should be connected in parallel, not in series. Okay, you can see starting and ending point, both the startings are connected, both the endings are connected, then you can say that it is in parallel connection. And we have to also mention the earthing wire here. Okay, so if you have any doubts, if you want to know anything regarding this pneumatic circuit, kindly mention in the comment section so they can check and respond to you accordingly. Thanks for watching, and please